So, welcome back students. The next exercise of class 11, chapter 3. The important questions only will be solving here. So, 4 questions I have written on the board here. So, let us begin with the question number 1. Prove that sin square pi by 6 plus cos square pi by 3 minus tan square pi by 4 is equal to minus 2. So, students, what you have to do here is you have to take the left hand side, simplify the left hand side, and you have to get the right hand side. If you do this much, prove that has been finished and you will be awarded with the marks. Alright, so let us start with this. The very first question, let's begin with the solution. So, solution. So, sin square pi by 6, what is pi students? 180 degrees. 180 divided by 6, 180 by 6 will be 30, correct? So, this will be sin square 30 degrees. Next, cos square pi by 3. Pi is again 180, 180 by 3 is 60, correct? So, this will become cos square 60 degrees minus pi is 180 again, 180 divided by 4, that will become equal to 45. So, that is tan square 45 degrees. So, we have taken only the left hand side, we have to get the right hand side. What is sin 30 students? 1 by 2, but you see the square here, the whole square, plus cos 60 is also the same thing, 1 by 2, the whole square, minus tan 45 is 1, the whole square. Now students, how am I writing these values? These values is about your trigonometric table which you have studied in your class 10th. Sin 30 is 1 by 2, sin 45 is 1 by root 2, sin 60 is root 3 by 2. So that table which is having different values, different angles of various trigonometric ratios. So from that table we got these values. So basically this is very important, you have to remember this. Apart from that, you have to know pi radians. Okay, pi radians is equal to 180 degrees. So this I have already discussed in the synopsis. The same thing, 180 divided by 4, 45, 180 by 3, 60, 180 by 6 is 30. So further simplifying this, 1 by 2 the whole square is nothing but 1 by 4. A quarter, one more quarter, minus 1. So quarter plus quarter, this will be equal to how much? Half. Half minus 1. So half minus 1 is nothing but minus of half, which is equal to the right hand side. So hence we have proved the first one. Understood? So we have to square here. So this square is very important. Squaring 1 by 2 will become 1 by 4, 1 by 4 minus 1. 1 by 2 minus 1 is minus 1 by 2, which is equal to RHS. Okay students. So the first one has been proved. Very simple. What is very important here is you have to remember these values. Basically you have to remember the table. Okay. Moving on to the next question. Same thing, you have to prove it again. 2 sin square pi by 6 cosecant square 7 pi by 6 into cos square pi by 3. Now students, see this, solution will start. Solution. Pi by 6 we can find out, right? What is pi by 6? 180 by 6, that is 30. Write that. 2 sin square 30 degrees. Okay, plus. Leave the blank here. We'll go here. Pi by 3, 180 divided by 3 is nothing but 60. So here we will write cos square 60 degrees. So this is done, this is also done, only this we have to work it out now. Okay, so 7 pi by 6, we'll draw a line here. Okay, use this as a working column. Okay, 7 pi by 6, so that is nothing but 7 into 180 divided by 6, correct? 7 into 180 divided by 6. 6 ones are 6 30s are, which is equal to 210 degrees. Which 210 degrees students? Cosecant 210 degrees. Now do you know what is the value of cosecant 210 degrees? Is that present in the table of values? Okay, that is not present. So how do we find out the value of cosecant 210 degrees now? We will be using Astc rule. Very important rule. Okay. So according to Astc rule, how can this be written as? This can be written as cosecant 180 plus 30 degrees. Is that correct? What is 180 plus 30? 210. Why we are using 180 and 30 only? Because students, 180 is present in the Astc table diagram and 30 is present in the table. So students, remember always, whenever you want to expand or whenever you want to rewrite these values which you don't know, always try to rewrite in the standard forms like this, 180 plus 30 or 270 minus 60, that is also equal to 210. That is also possible, but we have taken this one. Okay. Now 180 plus 30 means you have to expand this with respect to Astc rule and the table only. Okay, you cannot write 200 plus 10. That is expressing 210 not with respect to the table and Astc rule. Okay, always try to expand or express this 210 with respect to the table and Astc rule. Okay, this is the one point which you have to remember. 180 plus theta, this is in the form of what? 180 plus theta, right? 180 plus theta lies in which quadrant? 180 plus theta lies in the third quadrant. In the third quadrant, cosecant is positive or negative? Cosecant is negative. Which are positive in the third quadrant? A, S, T. So tan and cot are positive in the third quadrant. Other ratios are negative. So we are writing a negative symbol for cosecant. So we'll write cosecant as it is. Since we are getting 180, 30, so there will be no change in the ratio. So this is cosecant 30 degrees. So what is cosecant 30 degrees now? Cosecant 30 degrees from the table will be equal to 2. Okay, so this is minus sign there, we'll write minus 2. We'll come back here. So cosecant 7 pi by 6. 7 pi by 6 is nothing but 210. Cosecant 210 can be again written as 180 plus 30, which is nothing but cosecant 30 is minus 2. So here we will write cosecant square 210 degrees. This is a dot into cosecant 210 into cos square 60. Substituting the values here, students. 2 into what is sine 30? 1 by 2 the whole square plus cosecant 210. What is cosecant 210? Minus 2 square we have here. So minus 2 the whole square into what is cos 60? Cos 60 is again 1 by 2. 1 by 2 square we have. So the whole square. Students, are you understanding this? This value is easy, directly we wrote. This value is also easy, so directly we wrote. This we had to calculate. We calculated, we got 210. We expressed 210 with respect to the Astc rule and the table. Once we express that, okay, we can find out what is the value of this and we have squared that. Very simple. Now, simplify this further. So this will become 2 dot 1 by 4 means into plus this will become minus 2 the whole square will become 4 into this will become 1 by 4. So 4 and 4 will get cancelled. 2 1s are 2 2s are. So here the answer will be how much? So 2 1 by 2. 1 by 2 plus 1 equals. So it was 2 1s are 2 2s are 4 and 4 will get cancelled. 1 by 2 plus 1. So take LCM and add this up. You will be getting 3 by 2 which is equal to RHS. And hence the second one is also proved. Understanding? So here students, if you get this type of values, put a working column on the right hand side. So I have put it up above here. Okay, work this out. You will be getting the value. Just square that and simplify further. You will be getting the right value. So students, very important. See, this step is full of simplification. Correct? You are using trigonometry here. What are you using of trigonometry here? Here you are using table and ASTC. Okay, so this is being used in this step. Apart from that, in the very first step, you are using pi radians is equal to 180 degrees. So if you observe this problem, only these both things, okay, you must be knowing. Apart from that, the other steps are simplification. Understanding? Okay. Moving to the next problem, question number 3. Cot square pi by 6 plus cosecant 5 pi by 6 plus 3 tan square pi by 6 is equal to 6. We have to prove this. Take the left hand side. Pi by 6. How much, students? 180 divided by 60. 180 divided by 60, sorry, 180 divided by 6, that is equal to 30. So solution will start here. So this will become cot square 180 by 60 is 30 degrees plus cosecant 5 pi by 6. Cosecant 5 pi by 6 will do it here, students. 5 into 180 divided by 6. 6 1s are 6 30s are, which is equal to 150 degrees. So cosecant 150 degrees we have to find out. So cosecant 150 can be written as cosecant 180 minus 30. Correct? What is 180 minus 30? 150 only. 180 minus theta lies in which quadrant? 180 minus theta lies in the second quadrant. In the second quadrant, what is happening, students? What is positive in the second quadrant? Referring to Astc rule, sine and its inverse are positive. So we'll write plus because cosecant is positive in the second quadrant. And we have cosecant 30. Previously also we got cosecant 30 only. So here we had minus, so we written minus 2. This time we have plus. So we'll be writing what? Plus 2 here. Okay. So therefore, what is this plus 2? Plus 2 is nothing but this. So write 2. Directly we have written the value, or else you can also write cosecant 150 degrees plus 3 tan square pi by 6. Again, pi is how much, students? 180. 180 divided by 6 is 30. So this will become 3 tan square 30 degrees. By looking at the table again, table of trigonometric ratios, cot 30 will be equal to root 3 the whole square plus cosecant 150, that is nothing but 2, write 2 as it is, plus 3 tan square 30. Tan 30 is 1 by root 3 again. 1 by root 3 the whole square. This is tan square 30. So you see this 3 here. So into 3. Okay, now solve this. Square and root will get cancelled. Square and root will get cancelled. So we'll be having 3 plus 2 plus 1 by 3 into 3. 3 and 3 will get cancelled. So 3 plus 2 plus 1, which is equal to 6, which is equal to RHS. Hence, we have proved this problem. Okay, moving on to the next one, question number 5. Find the value of sine 75 degrees. Now students, understand this. Can you express 75 degrees with respect to Astc rule and the table? If so, how can you do that? So according to the Astc rule, okay, you can use which all number, students? 90, 180, 270 and 360. So if suppose you take the least value 90, if you take 90, then you have to subtract 90 with what? 15. But 15 is not present in the table, right? So whenever you get these type of values, what we'll do? We'll be using compound angle formulas of trigonometry. What are compound angle formulas? So here we'll start solution. Sine 75 can be written like this, students. Sine of 45 degrees plus 30 degrees. Now students will be telling, sir, we can also write sine 75 degrees as sine 70 degrees plus 5 degrees. 70 plus 5, that is also equal to 75. Why are we not using that? Very simple, students, that is not with respect to the table. See, sine 45 is in the table, 30 is also in the table. So that is why we are expanding 75 as 45 plus 30. You can expand 75 as 50 plus 25 also. But what is the use? You do not know the values. Understanding? So that is the catch here. So you have to express in such a way that you know the values of the particular trigonometric ratio. Now see this. This is in which form? Okay, we'll write down the formula here. This is in the form of sine A plus B. What is sine of A plus B? Sine A cos B plus cos A sine B. Compound angle formula. Similarly, use this. What is in the place of A? We have 45. What is in the place of B? We have 30. So this will be equal to sine 45 dot cos 30 plus cos 45 dot sine 30. You know these values, right? Because you have the table. Now substitute those values. Sine 45 is 1 by root 2. Cos 30 is root 3 by 2. Plus cos 45 1 by root 2. And sine 30 is 1 by 2. Is this correct? Sine 30 1 by 2, cos 45 1 by root 2, cos 30 root 3 by 2, sine 45 1 by root 2. Now see the denominator, students, 2 root 2, see the denominator here 2 root 2 as well. So the denominators are same. So whenever the denominators are same, we can add up the numerators. Denominator 2 root 2, add up the numerators now, root 3 plus 1. This is equal to how much? Sine 75 degrees. So 3 problems we saw here, students. 3 problems in total, 1, 2, 3 and 4. What are very important, students? What did you understand? You have to know the trigonometric table. You have to know that pi radians is equal to 180 degrees. You have to know the Astc rule in order to expand this unknown values. 3 things. Apart from that, whenever you get these values, which cannot be expressed with respect to the table and Astc rule, okay, you have to make use of the compound angles. And while splitting this number, you have to split with respect to the table again, 45 and 30. So that you know the values and you will be getting the final answer. So these are 4 problems, the very first 4 problems of 3.3, important ones. Okay, moving on to the next one. Question number 6. So read the question here. I have written PT, which refers to prove that. Okay. So prove that cos pi by 4 minus x into cos pi by 4 minus y minus sin pi by 4 minus x into sin pi by 4 minus y is equal to sin of x plus y. So I have to prove the students. So I'll tell you, we'll start with this solution. So just observe the question here. Cos, you take this minus x as a, okay, and minus y as b. Minus x as a, minus y as b. Now read this, cos a into cos b minus sin a into sin b. What is cos a, cos b? So here we'll write, students, cos a dot cos b minus sin a dot sin b. This is equal to what? This is equal to cos of a minus b. Is that correct? Yes or no, students? Which formula is this? This is compound angle formulas. Okay. So this is in this form. So we will rewrite the given thing. Okay, by using this identity, we'll just rewrite this thing. So this can be written as cos of a minus b. What is a, students? Pi by 4 minus x. Minus, what is b? Pi by 4 minus y, but we have minus sign, so this will become minus and this will become plus. Correct? So this will become minus of, sorry, here it is plus. Pi by 4 minus y. Once again, cos of a plus b is equal to cos a cos b minus sin a sin b. Okay, I'll just rewrite this again. Here, cos of a minus b equals cos a cos b plus sin a sin b. Okay, this is the actual compound angle formula. Cos a cos b minus sin a sin b is equal to cos of a plus b. Cos a cos b plus sin a sin b is equal to cos of a minus b. Understanding? So there was a small mistake here which is rectified again. Now what will happen, students? We'll solve this again. So this can be again written as cos of pi by 4 plus pi by 4, correct? Minus, you take common, x plus y. What is pi by 4 plus pi by 4? Pi by 4 plus pi by 4 is equal to, add them both, cos, denominators are same, add up the numerators, it will become 2 pi, 2 1s are 2 2s are, so it will become cos of pi by 2 minus x plus y. Now you see this is in which form, students? This is in the form of cos 90 minus theta, correct? Pi by 2 is nothing but 90. This we are taking it as theta. Now 90 minus theta lies in which quadrant? 90 minus theta lies in the first quadrant. And what is positive in the first quadrant? All are positive in the first quadrant. So we will write this is equal to plus. Why? This is in the form of 90 minus theta. 90 minus theta lies in the first quadrant. In the first quadrant all are positive. All means what? All the trigonometric ratios are positive. So we have written plus here. Now since 90 is coming, what will happen? This ratio will get changed. So that will become sine. So for what values will the ratios change, students? 90 and 270. I have explained this in the synopsis, Astc rule. You can just refer to that. So this is becoming sine now due to this 90. Now theta must be written as it is. What is theta? Of x plus y. Now check, is this our right hand side? Sine of x plus y, which is equal to RHS. Here you can write hence proved. Understanding? So what is very important here? This part, the compound angle part. This formula you have to know. You have to identify this question, relate it with this compound angle formula, convert the given thing into like this, simplify. After simplifying, again you have to recognize this is in the form of 90 minus theta. You have to know that 90 minus theta lies in the first quadrant, and you also have to know that in the first quadrant all are positive. So since all are positive, we are writing this sine of x plus y and we got RHS and hence proved. So students, basically you have to know Astc rule, compound angle formulas and basics of trigonometry, which are all covered in our synopsis. So if you have not seen that, kindly watch that. Okay, this problem will be very clear to you. Understand? Okay. Moving to the next question, number 8. Again we have to prove that PT. Cos pi plus x into cos of minus x, sin pi minus x cos of pi by 2 plus x is equal to cot square x. We have to prove this. Solution. Pi is how much, students? 180 degrees. So cos of 180 degrees plus x into cos of minus x the whole divided by sine of, again what is pi? 180. 180 minus x into pi by 2 is 90 cos of 90 degrees plus x. Now one by one students. So here we'll start. 180 plus theta lies in which quadrant? So this is in the form of 180 plus theta. This is in the form of 180 minus theta. This is in the form of 90 plus theta. This is in the form of minus theta. 180 plus theta lies in which quadrant? 180 plus theta lies in third quadrant. Minus theta lies in which quadrant? Minus theta lies in fourth quadrant. 180 minus theta lies in which quadrant? 180 minus theta lies in second quadrant. And 90 plus theta lies in which quadrant? 90 plus theta also lies in second quadrant. What is happening in third quadrant students? ASTC. So here you see ASTC. 1, 2, 3, 4. 180 plus theta lies in third quadrant, right? What is positive in third? Tan and cot. Others are negative. So write minus, because 180 plus theta lies in third quadrant, cos is negative, so we wrote minus. 180 is coming, the ratio will not change. This will remain as it is, so it will become minus cos x. Okay, dot. See the next one. Cos of minus x, minus theta. Minus x is in the form of what? Minus theta. Minus theta lies in which quadrant? Fourth quadrant. In fourth quadrant, what is positive? Cos and secant are positive. Cos and its inverse are positive. So cos of minus x will become cos x as it is. The whole divided by, come to this one now. 180 minus theta. 180 minus theta lies in which quadrant? 180 minus theta lies in the second quadrant. So in the second quadrant, sine is positive, sine and its inverse are positive. So here we will be writing sin x. Ratio will not change because what is this? 180 is coming, so the ratio will remain as it is. Coming to this part now. Cos of 90 plus x. 90 plus x lies in which quadrant students? 90 plus x lies in the second quadrant again. So this will become, so since 90 is coming, what will happen? Since 90 is coming, what will happen? The ratio will change. And cos is positive or negative in the second quadrant. See 90 plus, this is in the form of 90 plus theta. 90 plus theta lies in the second quadrant. In the second quadrant, only sine and its inverse are positive. Here what do we have? Cos. So we'll be getting negative here. 90 is there, so it will change into sine x as it is. So what do we have in the numerator now? Minus cos square x divided by minus sine square x. So there is a into symbol here, dot. Okay. So minus and minus will get cancelled. So cos by sine is cot square x, which is equal to RHS. Hence proved. So in this particular problem, what is very important? You see this here. These things. 1, 2, 3, 4. Basically what is important students? ASTC rule. So if you know ASTC rule very well, you can easily solve this problem and you will be getting the right answer. Okay, moving on to the next question. So students, see these type of problems, whatever we are doing in this session, all these are important problems of trigonometry. So especially this problem, so you solve more of these kind of problems, you know what will happen, you will get stronger in your concepts. So this is one of the conceptual problem which we are going to solve right now. So the question is, prove that we have to take the left hand side and we have to prove that it is equal to 1. Alright, we'll start with the solution. So students, what is the concept being used in this problem is the ASTC rule only, nothing more. Okay, so cos of 3 pi by 2 plus x, what is this equal to students? Let us see what is this equal to first. Okay, let us see what is this equal to. 3 pi, 3 into 180 divided by 2. 2 1s are, 2 90s are, so 90 into 3 is 270 degrees, correct? Similarly, we'll take this, so 2 pi, this is nothing but 360 degrees, correct? 3 pi by 2, same thing only students, 3 pi by 2, 3 pi by 2, so this will also be equal to how much? 270 degrees. 2 pi is again nothing but equal to 360 degrees. Now we'll rewrite the question again, okay, we will just rewrite the question, but this time with the help of the degrees, not with the help of the radians. So we'll write this, cos 270 plus x, correct? 270 plus x dot cos 360 plus x of cot 270 minus x plus cot again 360 plus x. What we have taken the left hand side and we have written in terms of degrees. Okay, the question was given in terms of radians. We have just converted that into degrees. First step, very first step, conversion. After the first step now, here we'll write Astc rule. Very short and small. Astc 1, 2, 3, 4. Keep that aside. Why we have written that? Okay, just to solve this now, students. Okay, conversion, the very first step is what? Conversion of radians into degrees. Now the second step, identification. 270 plus x, this is in the form of what? 270 plus theta. Okay. 360 plus x, this is in the form of what? 360 plus theta. What is in the place of theta, students? X. Theta, x. This is in the form of 270 minus theta. This is in the form of 360 plus theta. What we did? First step, conversion from radians to degrees. Second step, identifying the degrees here or identifying the angles. Okay, we have identified that. Now the third step, classify these angles. Classify means what? You have to tell this angle is belonging to which quadrant, this angle is belonging to which quadrant, or where are they in the Astc rule. 270 plus theta lies in which quadrant, students? So this is 270. So here you write again 0, 90, 180, 270. Again this is 360. This is 270. 270 plus theta lies in the fourth quadrant. In the fourth quadrant, what is happening? Cos and secant are positive. What do we have here? Cos. So this is positive. So here we'll write which is equal to plus. Why is this positive, students? Because 270 plus theta lies in fourth quadrant. In the fourth quadrant, cos and secant are positive. So we have written positive. Now the next thing is, since 270 is coming, what will happen? The ratio will change into sine. So students, I have explained this earlier also. For 270 and 90, the ratio will change. For 180 and 360, the ratio will not change. Remember this. Okay. So this will become sine. Write x as it is plus sine x. Okay. Next. 360 plus theta lies in which quadrant, students? 360 is here. 360 plus theta lies in the first quadrant. In the first quadrant, what is happening? All are positive. Since all are positive, what will happen? Dot plus. Because all are positive, right? So we have written plus. 360 is coming. Will the ratio change? 360 and 180 ratio will not change. So we will be writing it as it is cos and the degree as x. This is done. Of 270 minus theta lies in which quadrant? 270 we have here. 270 minus theta lies in the third quadrant. In the third quadrant, tan and cot are positive. What do we have here? Cot. So what will happen? Positive. 270 is coming. What will happen, students? The ratio will get changed. So cot will become how much? Tan. And the degree as it is x plus 360 plus theta. So this is 360 plus theta lies in which quadrant? First quadrant. First quadrant, what is happening? All are positive. What do we have here? Cot. So we are writing plus as it is. Since 360 is coming, will the cot change? 360 means no change, students. Cot will remain as it is. So just write cot and x as it is again. Understanding? So this is what we got. Conversion of radians to degrees, identifying these lying in which quadrants. According to Astc rule, we have rewritten this as it is again. Now we have sin x dot cos x of tan x plus cot x. We'll solve this further. Sin x into cos x of tan x plus cot x. Now students, tan x plus cot x is inside the bracket and outside what do we have? Sin x and cos x. So whatever is inside the bracket, we'll try to convert it in terms of sin and cos. Why are we doing this? Just to get 1, students. Okay, you'll understand this here, which is equal to sin x into cos x of sin x by cos x, that is nothing but tan x plus, here we have cot x, cos x by sin x. Correct? Now take the LCM. What will happen? Sin x dot cos x as it is, sin square x plus cos square x, cos into cos, cos square, sin into sin, sin square, the whole divided by sin x dot cos x. Correct? These both will get cancelled since there is multiplication sign in between. What is remaining inside the bracket? Sin square x plus cos square x, which is equal to how much? 1, which is equal to RHS, hence proved. So here students, what is very important? See here, radians to degrees, degrees, identifying the degrees with respect to Astc rule. After identifying with respect to Astc rule, solving them. What do I mean by solving? 180 and 360 no change, 270 and 90 change. Okay. After solving, simplifying sin x by cos x, cos x by sin x. Simplification again, LCM. Finally we'll be getting the answer. Here we are using what? Trigonometric identity. So students, if you summarize this problem, what are we using here? First one, conversion. Second one, identifying. Third one, using Astc rule. Fourth one, trigonometric identities. So again, these four are covered in the synopsis only. So basically students, this is very important. You have to know all these things, which are the formulas of trigonometry. So once you know that, you see these all are simplification part. Okay, taking LCM, writing tan as sin by cos. Okay. So once you do this, you will be getting the right answer, and hence this will be proved. So it's 4 steps. These 4 points are very important to solve this problem. Understood? Moving on to the next question now. Exercise 3.3, 11th question. So before we start with this problem, okay, on my left hand side, we have some formulas here. So the formula, the heading of this formulas are both together, these both together are called as transformation formulas. So it is again divided into, this is the first one, product to sum. So students, see here, product is written, correct? So we have the product on the left hand side, into and into. From product, we are getting what? Sum. So product to sum. You see the sum here? Okay. So product to sum formula this is. And the next one is called as sum to product. You see the sum, right? So here we have the sum to product. So here we have the product. Product to sum, sum to product. So this is both together are called as what? Transformation formula. Means transforming product to sum and vice versa. Sum to product. So we can prove each one of these formula, students, but proof will not be asked in your examinations as well as in your competitive examinations. So what will be asked is, you have to know these formulas. The first 4 in the first one, product to sum, and the second 4 in the second one, that is sum to product. So now on, means from question number 11 onwards, in exercise 3.3, we will be using these formulas. So we'll keep this side as it is. Okay, we'll be using this and solving these problems. Understood? So let us begin with the very first question using these formulas. Number 11 we have. So here we have to prove that cos of 3 pi by 4 plus x minus cos of 3 pi by 4 minus x is equal to minus root 2 sin x. So this is what we have to prove. We'll take the left hand side, simplify this, solve this, we should be getting the right hand side. So let us begin with this. Let us start with solution. Okay, so what do we have on the left hand side? Cos of 3 pi by 4 plus x minus cos of 3 pi by 4 minus x. So this is resembling which formula, students? If you see here, is it resembling the second one here? Cos a minus cos b equals minus 2 sine of a plus b by 2 into sine of a minus b by 2. Is that resembling that? So we'll use the formula. Directly we'll write this second formula we are using here. So we'll write minus 2 sine, what is in the place of a, students? 3 pi by 4 plus x plus, in the place of b we have 3 pi by 4 minus x dot sine again A minus B, what is A again? So this whole divided by 2. Okay, by 2. A minus B, what is A again here? 3 pi by 4 plus x minus B. So that will become 3 pi by 4 plus x, correct? If you substitute the minus or distribute the minus sign inside, it will become minus and it will become plus. Minus into plus, minus, minus into minus, plus. The whole divided by 2 again. What formula we used here? We got the sum, we converted it into product, and this is what we have written. So directly I am telling, we have used this formula here. Simplify this further, plus x and minus x will get cancelled. Plus 3 by 4 minus 3 by 4 will get cancelled. What will be remaining? Minus 2 sine of 3 pi by 4 plus 3 pi by 4. Denominators are same, which means you can add up the numerators. So that will be 6 pi by 8, correct? 6 pi by 8 dot. So this is becoming sine of x plus x is 2x by 2. Further simplify this further, students. What will be getting? This plus 2 and 2 will get cancelled. 2 3s are 2 4s are, correct? Rewrite this again. Minus 2 sine 3 into 180 by 4, converting the radians into degrees, into sine x as it is. 2 and 2 got cancelled, correct? So now this is becoming 4 1s are 4 4s are 16. What is the remainder? 2. So 4 5s are 20. So 45 into 3. So 90 plus 45, 135. So here we'll be getting minus 2 sine. 45 into 3 is how much, students? 135. 135 can be expressed as what? 135 can be expressed as 180 minus 45 degrees, correct? 180 minus 45 is 135. So 135 is what we got here. So 180 minus theta lies in which quadrant, students? Using Astc rule here, 180 minus theta lies in the second quadrant, and in the second quadrant sign is positive. 180 is coming, so the ratio will also not change. So this we will write it as it is, sin x. So whatever I explained here, it is all about Astc rule. So Astc rule I have explained in the synopsis as well, correct? So please go through that, it's very important. Here we'll write again, minus 2 sine 45 degrees into sine x. Now simplifying further, sine 45 can be written as what, students? See what we have to prove, minus root 2 sine x, correct? So now sine 45 can, this 2 we have, minus sign will write as it is. This 2 can be written like this, root 2 into root 2, correct? This is nothing but this single 2. So root 2 the whole square, square and root will get cancelled, will be getting only root. So understand, instead of this 2, I have written root 2 into root 2 into, what is sine 45? 1 by root 2 into sin x as it is. What will happen? This root 2 and this root 2 will get cancelled. What is left out, students? Minus root 2 into sin x, which is equal to RHS. So therefore, hence proved. Minus root 2 sin x, minus root 2 sin x. Was it easy? Yes. So students, what you have to know here is, you have to know the transformation formula. So by heart these formulas, we can prove each of these formulas. Even I can prove this in the class, but the proof will not be asked in your examinations. So only the application. So if you remember this one, so for example, we use this formula here, right? So if you know this formula, you can use that here and you can prove whatever is asked. So basically memorizing these formulas are very important. So memorize this, and also what is very important here, Astc rule. So these both are very important. So with the help of these both things, we could solve this problem very easily, and we have also proved it. So moving on to the next question now. So again, I prove that problem, same exercise, question number 13, we'll start with the solution. Okay, so here we have cos square 2x minus cos square 6x is equal to sin 4x into sin 8x. This is what we have to prove. Okay, so we'll take the left hand side. This is in which form, students? A square minus b square, correct? A square minus b square is equal to what? A plus b into a minus b. What is a? Cos 2x. A plus b into a minus b. Now here again, so how did we get this step? We simplified this using the formula. We got a plus b into a minus b. This is in which form again? Look to the transformation formula. Cos a plus cos b. And this is equal to cos a minus cos b. See, if you know these formulas, how simple it is. Correct. So we'll use these formulas now directly. So what is cos a into cos a plus cos b? Transformation, sum to product. Cos a plus cos b, students, here. 2 cos. So we will directly write 2 cos a plus b by 2. What is a? 2x. What is b? 6x. 2x plus 6x. 8x. 8x by 2, it will become 4x. Understanding? So a plus b by 2, 2x plus 6x, 8x. 8x by 2, 4x. Dot cos a minus b by 2, a is 2x, b is 6x. 2x minus 6x minus 4x. Minus 4x divided by 2 minus 2x. Understanding? We wrote that as it is, so we will write this inside the bracket. So this is done. Now writing here, we will open the bracket again. Cos a minus cos b. See here students, cos a minus cos b. Minus 2 sine. So start with the minus. Minus 2 sine a plus b by 2. 2x plus 6x divided by 2. 2x plus 6x, 8x. 8x by 2 is 4x. Into sine a minus b by 2. A, 2x minus b. 2x minus 6x minus 4x. Minus 4x by 2 minus 2x of minus 2x. Close the bracket. Understanding how are we doing this? We use this formula. We got this one. Now again using these both formulas, we got this. Now simplifying this further, how will this get simplified further? Now this is in which form, students? This is in the form of cos of minus theta, correct? This is also the same thing, sine of minus theta. What is cos of minus theta? Cos of minus theta is plus cos theta. What is sine of minus theta? Sine of minus theta is nothing but minus sine theta. Why minus sine theta and why plus cos theta? Astc rule, transformation formula, algebraic formula. Understanding, students? So basically formulas only, everything. Simplifying this further, what will happen? We'll write the next step, which is equal to 2 cos 4x dot cos 2x into, so this is becoming minus sine theta, right? So this minus into this minus, it will become what, students? Plus. See, instead of this, what should we write? Instead of this, we have to write minus sine 2x. So minus into minus will become plus, right? So this will become 2 sine 4x dot sine 2x. What should we prove, students? We have to prove this is equal to sine 4x into sine 8x. We will rewrite this again, which is equal to, so there is a multiplication symbol throughout. There is no plus and minus symbols. Okay, you can just see that. Why? Because we have used sum to product. So everything is in terms of product only. We'll rewrite this 2 sine 4x into cos 4x dot 2 into sine 2x into cos 2x. Now students, we'll be using another formula here which is called as multiple angle formulas. So here I'll write the formula. Sine 2x equals 2 sine x into cos x. Now very simple, students. Here we have written x. Leave this 2. Okay, leave that 2. Do not see this 2. Only see this. Here we have written x. That is why we have written x here as well as we have written x here also. Understand? Now what do we have here? 4x we have. Which means what? Here we have written x. Here also we have written x. That is why we have written an x here. Here we have 4x means this can be written as what? 2, sorry, it's not 2 here. sine 2x, right? So this will be sine 2x. But in the place of x, what do we have here? 4x. Here we had x only. So we wrote x. Now we have 4x means, open the bracket, write 4x. Which formula we used here? Multiple angle formulas. Same thing. Here we have 2x. So this will become what? 2 sine 2x into cos 2x. It will become, sine 2 into, what is in the place of x, students? 2x we have. Write 2x as it is. Simplify this further. This will become equal to sine 8x dot sine 4x, which is equal to RHS. Therefore, proved. Understood? So what is very important? Algebraic formula, transformation formula, sum to product, Astc rule, multiple angle formula. So these 4 formulas, if you know thoroughly, solving this problem is very easy. So students, just understand, if you know the formulas well, you can easily solve the problem. Moving on to the next question. We'll write solution first. So read the problem now. Prove that cos 9x minus cos 5x the whole divided by sin 17x minus sin 3x is equal to, we have to prove the right hand side. Okay. So we'll take the left hand side. Which form, students? This is in which form? Cos A minus cos B. This is in which form? Sin A minus sin B. So we'll directly write this ratio, okay, by using the formula. So cos A minus cos B, students, here, cos A minus cos B, minus 2 sin A plus B by 2. 9 plus 5 by 2 is 7x. Correct? Into sin A minus B by 2. 9 minus 5 is how much, students? 4. 4x. 4x by 2, 2x. We got it. Okay. So the above one is solved. Very similar to what? Cos A minus cos B. We got the answer here. Sum to product. Now the denominator thing, sin 17x minus sin 3x, sin A minus sin B. See here, students, last one. Sin A minus sin B. This is starting with 2 cos A plus B by 2. A is 17, B is 3. 17 plus 3 is how much, students? 20x. 20x by 2 is 10x. Into sin A minus B by 2. 17 minus 3 is how much? 17 minus 3 is 14. 14 by 2 is how much, students? 14 by 2 is 7. Correct? So this is sin 7x. Now see, what can you cancel? Sin 7x, sin 7x. And 2 and 2 also we can cancel. Anything else? That's all. Which is equal to this minus symbol as it is, minus sin 2x the whole divided by cos 10x, which is equal to RHS. Therefore, hence proved. Very simple what we used here. Transformation formula, product to sum to product. Once you use that, simplify, you will be getting the right answer. As simple. See, only one line we finished the solution. Moving on to the next one. So the next question, prove that sin x minus sin y by cos x plus cos y is equal to tan of x minus y. Very straightforward question. You have to know this formula, students. Very simple. Sin x minus sin y, what can we write here? Sin x minus sin y is very similar to sin A minus sin B, which is equal to 2 cos x plus y by 2 into sin x minus y by 2. The whole divided by cos x plus cos y, similar to cos A plus cos B. 2 cos x plus y by 2 into cos x minus y by 2. So here cos of x plus y by 2, cos of x plus y by 2 gets cancelled, 2 and 2 also gets cancelled. What is remaining? Sin by cos. What is sin by cos, students? Tan. Theta is same, x minus y by 2, which is equal to RHS. Therefore, hence proved. Moving to the next question. The next problem, 21st one, prove that again. Prove that cos 4x plus cos 3x plus cos 2x the whole divided by Sin 4x plus sin 3x plus sin 2x is equal to cot 3x. So students, again the same thing. We have to use what? But we have 3, right? Here we have only 2, cos A plus cos B. No plus cos C, right? But here we have 3 terms. So no need to worry. What we'll do, we'll consider only 2. Okay. So see, here we need 3x, right? 3x is there, cot 3x. So let this 3x be as it is. We'll be using 4x and 2x. Okay, we'll be considering these both in numerator and denominator, and we'll be using this sum to product formula. So we'll be using sum to product formula for, so this will be taking as A, this will be taking as B, same thing here, this will be taking as A, and here we'll be taking it as B. Now the very first one, students, cos 4x plus cos 2x is equal to, we'll write 2 cos A plus B by 2, 4x plus 2x, 6x, 6x by 2, 3x, into cos A minus B by 2, cos 4x minus 2x, 2x, 2x by 2, x, plus cos 3x as it is. The whole divided by sin A plus sin B. Here students, sin A plus sin B. 2 sin A plus B by 2, 2 sin 4x plus 2x, 6x, 6x by 2, 3x, into cos A minus B by 2, cos 4x minus 2x, 2x, 2x by 2, x, plus what we have, sin 3x. What can you take common here, students? Cos 3x, sin 3x, take them outside. This 2 and this 2 will get cancelled here only. So we'll take cos 3x common in the numerator and sin 3x common in the denominator. What will be remaining inside the bracket now? Cos 3x has come out, so we are left out with cos x plus 1. Correct? Here, same thing. Cos x plus sin 3x has come out, right? These both also will get cancelled. Cos 3x by sin 3x is equal to how much? Cot 3x, which is equal to RHS. Therefore, proved. Very simple again. What we did? Looking at the right hand side, we decided which to leave alone. So we left alone this. And for the rest of the things, what we did? We used product, sum to product, and we got the right hand side. And hence we have proved. Moving to the next question. The very last question of exercise 3.3, students, the important ones. Okay, the rest of the questions you can try. If you're not able to solve any questions, you can let us know by commenting in the comment section. So we'll also be uploading all these formulas and study materials in our website. You can access to that. With the help of those formulas, you can solve all the problems of your NCERT classwork. Sorry, NCERT textbook. Any problems you find very difficult, kindly let us know by commenting in the comment section. Okay, we'll try to solve those problems, and also I'll be explaining those particular problems. So the last question, same old thing, sin x plus sin 3x the whole divided by cos x plus cos 3x is equal to tan 2x. Sin A plus sin B, 2 sin A plus B by 2, x plus 3x, 4x by 2 is 2x, into cos A minus B by 2, x minus 3x is minus 2x, minus 2x by 2 is minus x, correct? X minus 3x, minus 2x by 2 will become equal to minus x, the whole divided by cos A plus cos B, 2 cos A plus B, so 2 cos x plus 3x, 4x by 2 is 2x again, into cos x minus, so A minus B by 2, right? X minus 3x is minus 2x by 2 is minus x. So what is this, students? This and this is in the form of cos of minus theta and cos of minus theta, which lies in the fourth quadrant. So this is equal to cos theta and cos theta, correct? Astc rule. So rewriting this again, so we can directly cancel this because both are same. 2 and 2 also will get cancelled. Sin by cos is nothing but tan 2x, which is equal to RHS. Hence, proved. So this is the end of this exercise 3.3. We'll meet you in the next class with the next exercise. Until then, stay tuned with Vista's Learning. Thank you.